very pleased to be able to introduce Andrew Powell from MathWorks, who is going to deliver the first of these talks in this session.
Thank you, Andrew. Well, good morning, everyone. Thank you very much, Andrew, to SDSC and IOP for welcoming me back to give a repeat of a presentation I gave last year, but hopefully I think it's all relevant and appropriate to you today. So before I begin the talk in earnest, I just thought I'd throw up something that's relevant in the media that I just discovered actually on Friday. So as of Friday, I still wasn't due to actually come to this event. I came last year, but as I'll describe later, as a software developer, there's moments whilst you're writing code that you actually have to compile code, and you'll just come on in. That's correct. Whilst you're compiling code, you have to wait of order of minutes, and you need stuff to do. So occasionally I catch myself reading the BBC News webpage and just happen to come across this. And this is an article, although it says, the title of the article, Maths Becomes Biology's Magic Number, it's actually all about a physicist, just like John Butterworth is describing, physicists who go off and do academia in different disciplines. So this is a physicist who actually, like myself, worked at CERN on the LHC, and he's now working in medicine. And if I go through to the next bit, there are actually quotes here from a professor of medicine at Oxford University who's saying physicists have skills which are absolutely essential to do modern day medicine. And actually to do medicine now, it pays you to actually qualify as a physicist first and then go off and do medicine. So I thought that was quite appropriate to show today. And hopefully it gives backing to what John was saying just a moment ago, and hopefully what I'm going to show to you now. So I thought that was quite good. But before I dive into who I am and what I've done and what software development is, I thought I'd just give you a preamble of things that I wish I knew about when I was in your situation. Okay, so I was in your situation, let's see, I was a PhD student finishing towards 2013. Okay. I think John gave a taste of this, but if you have a physics PhD, you really are sitting on a winning lottery ticket, okay? There are both financially and intellectually rewarding careers out there for you. You just go off and search for them. You've got to bear in mind, though, that you do have skills which are lucrative to a broad spectrum of careers and industries. The employers of those careers and industries, though, they may be aware that you have those skills, in which case you don't really have to sell yourself too much to get the job. They're going to be aware of it. They're going to welcome you with open arms. Some of those careers, though, it's not a well-trodden path for physicists to enter into, and so those employers are not going to be aware of your skills, so you really have to sell yourself. But once you start selling yourself, they're going to be amazed, I'm sure, by the breadth and depth of skills that you have, and they're going to, again, welcome you with open arms. So yeah, just to reiterate, it's really just a case of selling yourself appropriately to the employer that you're targeting, okay? Be aware that there is no all-encompassing crystal ball that's going to tell you exactly where you should go and what you should do, okay? You have to be introspective and ask yourself, what is it that I want, okay? Ask yourself what really motivates you and infuses you, and what could you see yourself doing? A really good question to ask yourself is, where do you see yourself in 5 or 10 years' time, okay? That's a question I asked myself, and it actually helped a lot when I was deciding what I wanted to do post my postdoc. And certainly don't feel that you're confined to a set of conventional careers, okay? I think there's some speakers here today that are certainly not from your typical career path that a physicist would take. So don't think that anything's off the table, okay? You can really go off and do anything that you might think is interesting. And finally, be aware that you're the only person in control of your career, okay? So be proactive about it, do your research, and talk to anyone who's got an opinion on it. Okay, it's all going to be useful information. So just a brief overview of the talk I'm going to give. So I'll overview my time in academia, what I did, what I loved and hated about it, my decision to leave academia, why did I leave, and why did I decide to go off into software. I'll then briefly describe what it's like to become a software developer and why software development is well suited to physicists. And I'll describe briefly what I do, and then some final advice if you decide that might be a career path that you're interested in. So my career path, I did my undergraduate studies at Imperial. I did an MPhys. And the thing which really pointed me in the direction I took for the next decade was a summer internship I did with the HEP department at Imperial. So I worked with the CMS detector group at Imperial, and it opened my eyes to the world of writing software that interacted with hardware and really cutting edge technology, and it was fantastic. I was hooked. So from there on in, I knew I wanted to do research in high energy physics. So I finished my MSci at Imperial and then went off actually to do a summer internship at CERN the following summer, which was fantastic. Had the best time of my life, it was brilliant. Then went off and did a PhD at Oxford, working on the LHCb experiment, which is one of the 4 LHC experiments based at CERN. I was very fortunate to work with a very ambitious supervisor. We started our research looking at CP violation parameter measurements at the LHC. And we actually found that if we analysed data from another experiment called CLEO-C, based at Cornell University in the United States, we could actually eliminate some really fundamental systematic uncertainties in our measurement and make a much more precise measurement of the CP violating phase gamma that we wanted to perform. So I was very lucky. I had 2 long-term attachments, one at CERN and one at Cornell University. So after 4 and a bit years of trying to get my PhD, I then became a postdoc. I was very fortunate to apply for what was then an STFC postdoc fellowship, and I was awarded that. I did that for 3 years and then transitioned into a career in industry, and I've been working for the MathWorks ever since. And so the MathWorks is a software company. Has anyone heard of MATLAB? Yeah, so we're the company, and not many people realize this, MathWorks is the company that write MATLAB. And there's also another product called Simulink, which a lot of engineers use for simulating their systems before they go off and build them. So yeah, I've been working with MathWorks ever since. Yeah, so my PhD, just to go into brief detail of what I did. So the LHC experiment is raison d'etre is to measure CP violating physics and search for new physics at the LHC in a complementary way to what the general purpose detectors CMS and Atlas are doing. We're looking for subtle hints. So I use the term we. I've still got that. I'm no longer part of the collaboration, so they are still looking for subtle hints of new physics through alternative methods to what they're doing at the general purpose detectors. CLEO-C actually ceased to be whilst I was a PhD student out there. I think it was in 2010. It was a charm factory tuned to a resonance such that charm mesons would come off, and these were quantum correlated particles, so you could do fundamental quantum mechanics with these particles, and that was really exciting. So that complemented the physics I was doing at the LHC. So my actual studies for my PhD, I started off because the LHC wasn't running at that point, we were still building the detector. And I was working with the Oxford group who were responsible for the ring imaging Cherenkov detectors. And this provided the all-important PID, or particle identification information, for us to actually identify what particles we're traversing for our detector. And this is a unique subdetector that is at the LHCb, unlike the general purpose detectors, CMS and Atlas. The physics studies I ended up doing, so as I mentioned, we did sensitivity studies. We didn't have data at this point, so it was all Monte Carlo simulation. So there was a lot of programming already at this point in my career. You know, I was learning to write analysis software in C++. So we were doing sensitivity studies to actually determine what precision we could measure the CKM angle gamma with based on 2 nominal years of running. This was always the term, what could you measure something with 2 years of nominal running? So that was my PhD. That was a contribution to my PhD from the LHCb. CLEO-C, they actually had data, which was fantastic. And they didn't have enough people to actually analyze the data and get the measurement that we wanted. So, like I said, I had a very ambitious supervisor, and he was very keen that we went over there, we measured it ourselves, got that parameter, and then we folded it into our analysis at CERN. So we actually made a world's first measurement of a quantum correlation parameter using that data from CLEO-C. Then I morphed into a postdoc, and things got interesting because the LHC turned on. So we had floods of data to analyze, and it was all hands on deck to actually analyze it and find something that was interesting. So my claim to fame within the LHCb collaboration was I was the first collaborator to reconstruct a Phi 1020 resonance, which is bread and butter physics, but at the time when you're just looking at through seas of dirty tracks and continuum plots on your invariant mass plots, this was a really nice thing to find. So that was quite an exciting time. Using the information from the rich detectors to identify those two tracks came from kaons, and that the invariant mass was commensurate with a phi 1020 was really exciting. In order to get this data, of course, we had to do a lot of offline analysis of the code, cleaning up the code, monitoring the performance of the rich detectors is vital. If you start losing PID performance, all that data subsequently is affected, and you're not going to get the result that you want. So you have to be continually monitoring this. So we had some really complicated online monitoring tools, again written in C++, to actually do this in real time. We got clever. We were able to repeat the experiment or the analysis we did with the CLIO-C data at Cornell and get a much better measurement of this quantum coherence factor that we did in my PhD, which was really good. And then, we got better again. So instead of all these rectangular cuts that we were using to clean up our samples, you can now use these multivariant analysis techniques. I'll come on to that later. I'm sure you're all aware of it. In particle physics, we call them multivariate analysis techniques, but in industry, in the real world, people call it machine learning. And it's important that you make that distinction, that the same thing's got a different name depending who you're talking to. So I'll come on to that later. And so when we had data, we were actually able to make a first measurement of this CP violating phase gamma that we were interested in, which was really great. Again, there was a lot of more software development. I was writing tools to determine the PID performance that we had with our rich detectors. And just on top of all this research we were doing at CERN, there was teaching of third and fourth year students. So what did I like and dislike about my experience as a PhD student and subsequently a postdoc? I'm sure some of you here are working on LHC experiments and are analysing the data from the LHC. You just cannot beat the buzz and excitement there is around the LHC and the discoveries. I mean, I really wish I was involved in at CERN when the Higgs discovery was made. It was, I was on the outside by that point, but I could still gauge and feel the excitement that there was in the community about all that. That's something you're never ever gonna beat, I don't think. There's the intellectual stimulation as well. That's something I really enjoyed. The ability to use cutting-edge technology. You're at the forefront of what we're able to do as humankind with some of the technology that we're using. This was really exciting. I found I was always advancing my skills and knowledge every single day, no matter what I was doing. It really was a vibrant international collaboration I was working in. People from all around the world, creeds, colours, religions. It was fantastic. All across the corridors of the building I was in at CERN, there was people from all around the world, and just sparking up conversation with anyone was, it was a real joy. So that was something I enjoyed. Everyone was smart, and you were really striving to achieve amazing things. You just, as an individual, you just can't contemplate how that's possible. But as a team working together, these things are possible, and that's something which is really exciting. Dare I say, I did enjoy teaching from time to time. It did gobble up the hours, and it was a lot of preparation work, but there was a sense of enjoyment out of that at the end of the day for me. And then you can't beat it, the international traveling to conferences and workshops. Before I actually went to CERN for as a summer student, I'd never actually flown or been through an airport before. So, going off in this direction, going off into particle physics opened up the world to me. So I traveled to pretty much every continent I could whilst I was a PhD and postdoc. It's a fantastic experience. There were certainly dislikes, however, with what I was doing as a PhD and subsequently as a postdoc. As I became a postdoc, you certainly start to realise that, these are fixed-term contracts you're on. Okay, and the one I had was initially a 3-year in-house contract with Oxford University, and I was very, very lucky to get the STFC fellowship, which again was only for 3 years. And it's really a case of you've got to do as much as you can in those 3 years to sell yourself and promote yourself to either, as we were discussing in the presentation before, to get that next postdoc position, or if you're really good, put yourself forward to get shortlisted for an academic position. so you've really got to use those 3 years to your utmost best to promote yourself and get all the research you can to make yourself look better ahead of the competition. This I didn't enjoy. There's also the expectation of, okay, you're very lucky, you've been offered that postdoc, or very, very lucky and you've been offered that academic position. It could be anywhere in the world, and the expectation is that you take it and you go, and your family have to like that, and you just got to get on with it. This wasn't something I was particularly happy with either. I also found that there was little career development with where I was. There wasn't the planning to develop me over those 3 years to make sure that I was in a good situation to promote myself for that next postdoc or that academic position. The hours were long. I was working ridiculous hours, especially when we got first data from the LHC. It was a case of working in the office during the day, go home, have dinner, analyze the data again because there's fresh data coming in, and it was all hands on deck to get those results ready for conferences. So yeah, the hours were long. Then you fold in the teaching, which I think is the next item on my list. You've just done all that research, you've been analysing the data all day, and then you've got to go home. It's 11 o'clock at night, you've got to do marking for a tutorial you've got to do the next day. So this was very demanding, and yeah, didn't like that. So I'll come onto this slide again later when we make a comparison with my dislikes and likes compared to where I am now in the company that I work with. So why did I even consider leaving academia and my life as a postdoc? Because I said that I absolutely loved the physics. It was so exciting, it was motivating, but there did come a point where it was clear that this wasn't for me. And the reason for that was my life priorities basically changed. How to put this? I have a family. I want to be close to them more often. Wife, children. It's more important that now than the sheer excitement of doing the research. So those were the motivations which steered me in this general direction to leave academia. And ultimately, in order to have that lifestyle that I wanted a full-time position which was fixed in a part of the world that I was happy with. And so that led me to basically say, yeah, I'm going to call it a quit on this. So what options were available to me? I had the realizations that I had to ask myself, what was it that I really enjoyed doing? There was something clearly which motivated me and kept me interested for those years whilst I was a graduate student and a postdoc. So what was it? And actually going to career services and having one-to-one consultations with careers advisors really helped me, first of all, drum up the questions which were important and find the answers to them. So the first one was, what motivates me? I came to the conclusion that it was developing solutions to demanding technical problems and doing that with software and technology. Okay. And what was it that really motivated me? Sure, there's the knowledge that you're doing fundamental physics and it's groundbreaking and it's never been done before, but there was also that element that it had some sort of impact on society and had some importance in society. So I wanted to make sure that whatever I did ticked off that box. And again, I mentioned this was a really good question to ask yourself. Where did I want to be in 5 to 10 years' time? I certainly knew I didn't want to be doing a postdoc. And I came to the conclusion that compared to my peers, I wasn't as competitive or in as good a situation as they were to get academic positions. So I knew that wasn't where I wanted to be. So I cut my losses and started looking for a career in the industry. So what did I consider? I really considered everything that was open to me. I think I mentioned I made this decision to leave academia with a good year left of my SCFC fellowship. So I had a lot of time to assess my options, go to as many careers talks, open days, work shadowing opportunities as I could. So the careers I considered were teaching, quantitative finance, medical physics, and of course ultimately software development. So how did I come to choose software development? So as I mentioned, I made the decision I was leaving with plenty of time to assess my options. And so like I mentioned, I found one of the best things I ever did was to go and organise a one-to-one careers consultation with the careers service at Oxford University. It felt like counselling, but it really did help. They pointed me in the right directions with resources. Like I say, got me asking the right questions for myself. I came out of that. I went in rather feeling very depressed and sort of a failure, because there was all this expectation that I had this STSE fellowship. I was at the crest of a wave, destined for greatness in the academic world, and I decided that I was leaving. So I went in there quite demoralised, but came out with such optimism and excitement because I was told of all these opportunities that were open to me. So again, if they did anything, they told me what opportunities and the breadth of opportunities that were available, but they couldn't tell me exactly what to do. So that was still up to me to go off and find out. So I think I mentioned I attended as many careers events, careers fairs, and there was actually an IOP event specifically for people with physics qualifications to see if they wanted to go off into teaching. I found that very useful. That concluded I didn't want to do that. But a lot of people there said that it was helpful in a positive way. I also, like I mentioned, I was very interested. I had colleagues who had gone off into medical physics, and this sounded very interesting to me because I said I wanted to have knowledge that what I was doing had some social impact and benefit on people. And that surely is the case in medical physics. Anyway, my mother has a medical background, and she organised a work shadowing for me of a senior medical officer at a hospital. Within about half an hour, I knew that was definitely not what I wanted to do. There's guts and bodies, and it turned out I'm quite a gory, quite a squeamish person. But that was useful because it ruled it out. Within half a day, I knew, done. I don't need to investigate that anymore. Ultimately, when I ruled out, some of these avenues, and then I just threw applications in, and that's helpful because, first of all, if they offer you an interview, you must be ticking some boxes. There must be something that's attractive about you to them, and so you get to learn about these companies when you go and meet them. There's an opportunity for them to sell themselves to you as well as you selling yourself to them. So, although many of those applications didn't turn out to materialize into anything positive, it was very helpful. But you've got to be careful you don't throw your hat into the ring too many times, because otherwise you're going to spread yourself too thinly and not be targeting your application successfully enough for those careers that you really, really are interested in. So after all that, it really became clear that, software, working for a software house was something that I wanted to pursue. You have to be careful though. There's the big term software development or software house. No two software companies are the same, okay? I like to think I work for an excellent software company. As I mentioned, it's really important for me that there's that take-home knowledge that I'm doing something good for society and community, and we have special projects with my company that guarantee that. I'm not sure that exists at every company. So caveat is, sure, you like writing code, but make sure you work for a company that suits you and your ethos, if you want. So I think John mentioned, I think it was the first of all the career paths that people with physics PhDs go off into, software development or data analysis, I think, as he had an alternative name for it, is a very large avenue which a lot of us go off into. Why is that? Well, I can tell you. From my software company, the MathWorks, we have a real affinity towards physicists. Okay, if I just look at my immediate small team, there's myself, there's my direct manager, and then his top manager, and that's this sort of organogram, if you want, of where we are with the UK company in the MathWorks based in Cambridge. All three of us are physicists. Now, if I look at my top manager, his team, which I think at last count was about 23 team members, 9 of which had physics PhDs. Sorry, I beg your pardon, 9 of them had physics undergraduates, and 7 of these had physics PhDs. So there was a real strong contribution of physicists to his team, and there must be a reason for this. Basically, modern day physics is essentially computer science. I mean, it'd be interesting. Who here is writing what they would consider a considerable amount of software or code to get the results they need for their PhD? I'm seeing everyone. So you're already developing skills.
There's also the theorist.
A theorist? Who's writing software to analyze data and come up with groundbreaking theories for their research? Oh, okay. Anyway, we get the idea.
That's not me, right?
Oh, okay. Apologise. I'll keep going. I would keep going to try and incorporate you into the step, but I don't know what to say. What you're doing is essentially you're doing software development. You know, you're writing code to solve problems. So that's the first tick. Okay. The challenges that you're facing. This is another question. Who is analysing data that is what you would term large? And when I mean large, it can't fit on your computer. People are a bit gingerly putting their hand up. I'm going to say about 50% of you. So this is what we call the big data problem. Okay. So this is a term that you should all be striving to use in your applications and in your interviews. You know, when they say, "Well, what do you do? What software do you write?" If you're writing code and the problem is how do you analyze all that code in a sensible amount of time, and the data is not accessible on just one machine, you're performing data analytics and you're doing big data. Okay, so this is a problem that we're all trying to solve, especially in software development right now. Who writes software which is one of these languages here? C++, Python, Java, or MATLAB? Fantastic. Employers are crying out for people who are competent in any one of these languages. So they're object-oriented languages. This is the sexy way to write code these days. Okay. So if you are writing code like this on a daily basis, which it sounds like, you are developing skills that many employers are crying out for. I won't ask, but I suspect most of you are writing your code in integrated development environments, IDEs as we call them. This is a skill in itself. Okay, learning how compilers interact with these environments. You know, this is really important, and it's vital that you know how to do this if you apply for a job in software development. And finally, this is a bit more niche, but if you're anything like me, the thing that really pushed me in the direction of particle physics was writing code to interact with hardware and the hardware element of it. If you're writing code within your PhD to interact with hardware, so it might be FPGAs, microcontrollers, DAQs, these are really unique skills. And again, there's a subset of industry out there which is crying out for your skills. So what are software companies looking for? The hard skills, I just mentioned them all, and you've all just proven to me that you have them. There's then the soft skills, which again, you all have, and I'll try and prove to you how that's the case. You need to be adaptable. Okay, so we don't all just work on one facet of work at any one time, and I'm sure this is the case with you right now. You're working on some element of research, you're probably doing teaching, you've got responsibilities in the department for other things, you're balancing many plates at one time. This is a skill, okay, that many companies are looking for. You're solving problems, okay? You must emphasize this when you're applying to companies. It might not be problems that they're necessarily aware of or how it relates to the problems they're trying to solve, but it's a skill in itself, problem solving. And communication. John made reference to this. You're going off to international conferences, you're in meetings all the time, you're trying to get your arguments across. These are skills that you should be aware of that you have and make the employer know about them. Because the topic that you're discussing or trying to argue might be different, but it's still the same at the end of the day. You're trying to argue your case, and this is a really important skill to have. So you all have these skills, you just need to get it across to the employer that you have them. So I mentioned this is what I did during my postdoc, and you all looked as bored as hell, I must admit, when I ran through this, because I am as well when I rattle this off. Do not summarize your skills in this way if you're going off into a non-physics career, okay? If you're going off into industry, no one's going to have heard what a phi 1020 resonance peak is. No one's going to have heard what a rich detector is. No one really knows what multivariant analysis techniques are. These are just jargon words that are not going to resonate with the person who's reading it. So it's vital that you identify the skills and experiences that you have, which are transferable, and communicate them in a language that the person reading your application or is listening to you will understand, okay? Put yourself in the best light possible to get that job. Yeah, another slide I've already shown, my likes and dislikes. So this was the likes and dislikes I had whilst I was a PhD and postdoc. How does it look now that I'm working for a software company? Well, I'm sorry to say, you just can't beat the fact that there's the buzz and excitement of the LHC and international travel to conferences and going around the world. That's just one of the perks of the job in academia, okay? However, everything else in the likes column, I can guarantee I still get through working in a software development role. Furthermore, all of the dislikes I had whilst working in academia have now gone. So I would say net overall, I'm a much more happy person where I am right now working for the company that I do. So just to give you a sense of what it's like to work in software development and how it relates to similarities and dissimilarities to academia. The work is certainly very exciting and dynamic. The work I always did in academia was inevitably within small teams, at most about 10 people, and you would work with them closely and solve the problem. That's very much the case in software development. You have to work to very, very stringent deadlines. If you don't meet that code ship, then there's going to be customers who are disappointed. And then depending on the company you work for, that might be just 10 people, that might be 1,000 people, or if you work for the IBMs and Apples, that might be millions of people. And yeah, unfortunately, just like in physics, you have to write documentation at every point. You know, if you're doing something which is worthwhile, you need to communicate that in documentation. The differences, there are quite a few of them. Everything that you do in software development is driven by customers, okay? They pay you, the company, to do the work. So you're constantly having to assess who the customer is and what do they want. Project planning. Yeah, this was something that maybe is also existing in physics, and I just wasn't privy to it because I was just a postdoc. But there's much more planning, I find, in software development, and you're actually only writing code 10% of the time. It's all about planning what you do such that when you actually sit down at your terminal, write the code, it's not a waste of time. Something which really took me by shock was you have your peers review your code before it goes out into the real world. You know, everyone, at least 3 people have to have looked at your code and gone, I vouch that it looks sensible. So when I first started, I learned that I really couldn't program. There were a lot of my colleagues who really go to town on your code, but at the end of the day, it's for the best of the code and for the customer and the software that you put out. The next stage of that is once we've reviewed the code and your colleagues have improved it for you, you then have a series of people specifically employed to be what we call quality engineers or testers. And they write code to basically throw a sledgehammer at your code to ensure that it's robust, it does not break, and there are no bugs. So something which is really quite impressive about the MathWorks is that we try and guarantee that there are no bugs in any software that we release. So in order to achieve that, we test our code for 6 months rigorously before it goes out by giving our code to these guys, these quality engineers, and they throw the kitchen sink at it to try and break it. And if they do, they send it back to you, and you've got to try and improve it. And it's only then that you can sort of go home and be rest assured that your code is out there in the real world and it's not going to break. And the visibility of the end product, this is certainly different from what it is in academia. When you write that research paper, I'm willing to bet there's only probably tens of people who will read it, and they're probably the reviewers. And then how many people are actually going to use that result and go forward? I mean, maybe I'm being a bit harsh. When it comes to software, like I say, it depends on the company you're working for, but you could have millions of people using your code to try and solve a problem that they're trying to fix. It's really it really is quite gratifying when you see your code out there being used by people in the real world achieving great things. Okay, I better wrap up. So I think I've got 2 slides. What do I do at the MathWorks? So I write a lot of C++ code, and it's in a team called the storage management team. But ultimately, this is cloud storage. Okay, we write synchronization tools for customers to get their data whenever they want it via the cloud onto the machines that they use. Just to say, it's not always about writing code. It's also about the planning. It's the teamwork. It's the testing. There is teaching aspects also to my job. I work with intern students. I go to careers events just like this. So it's not just about writing code. What should I say quickly here? Yeah, I better make this my last slide then. If you think that software development is for you, make sure it is for you, okay? Ask yourself what motivates you, what problems do you enjoy solving, do you have an interest in technology? If the answer to these questions is yes, then I think, yeah, you should consider a career in software development. How do you research those opportunities? Talk to everyone. Actually, my job, I managed to find out about the job just by talking to an ex-colleague in a pub. Okay, so it can just be literally just talking to people. But there are online resources such as LinkedIn and Glassdoor, which I know a lot of people find useful. And then there's the university career services. And once you actually make contact with these companies, scrutinize them, okay? They've got to promote themselves to you as well as you promoting yourselves to them, okay? Like John tried to get across, you really are in an advantageous situation with the skills that you have. You should be able to negotiate the terms of what you want with your career. And I think I better draw a line there. Okay.
Maybe time for a quick question. I'll just see if they're finishing next door.
Yep. So, yeah, what you just said, concerning this, I would really say that all that interests me, but I heard it before already. I'm also a theorist, so we use software every day, usually a lot of different ones, whatever suits to solve the problem, but among all them, for me, there was never any which was object-oriented. I never used any IDE. How could I sell myself in this case?
Unfortunately, the slide I had to skip over, I think, had a point which was relevant to this. I think a software company, especially my own, is looking for potential. So they're not looking for, you have absolutely used object-oriented code. They're looking for you to show skills which demonstrate that you would be able to acquire that. So I think as a final word, don't assume you have to go into these companies as an expert coder. Okay. In fact, this is a disadvantage in some cases. Most companies like the ability to nurture you and train you in the way that they want. I learned a lot of bad techniques and tricks in coding through my time as a coder as a postdoc. They've managed to wean them out by these code reviews I was mentioning, but do not think that you have to be an expert coder, just show the potential to be one.